Hi, I'm Mark from Northeast Power Systems. Welcome to NEPC Factory Talk. Today we're going to take a look at one of our power factor controllers. It's the Nokian model NC12, and we're going to look at how we get into the meter and set it up and make changes, so forth. Um, when we ship a bank, every bank comes with a settings document like this, and this spells out the actual parameters you're going to put into the meter. So you can use this as a guide, and I'll show you how to step through it. Another document you're going to need is usually it's page 1 or 2 from your build prints, your electricals. And we use this to determine the stage size, the placement of the CT for sensing power factor, sensing current, load current, and we're going to use these values to put into the meter. So here's the Nokian NC12. It's got a flip down cover, reveals some push buttons, and normally this is the default screen. It's going to, assuming you have current input and voltage reference input, you'll see a power factor there if it's working correctly. And that just tells you what the power factor of the load is that you're trying to correct. And it's, like I said, the default menu. So in order to make changes or to set the meter up, from here we need to hit the escape button, hold it in until the screen changes, and that brings up a menu. And as you can see, we're on the measurements menu. We're going to scroll down to the parameters menu. And once we do that, we'll hit enter to select parameters, and it's asking for a code to allow access to the menu. And the default code is the minus plus buttons together. Hold them in, and now we're into the parameters menu. So first thing we need to select is the type of system we're going to control. And in this case, it's telling us 2-quadrant. 0.5 to 50 kV is the range, and it's using a VT for a voltage reference. Now if we wanted to change that, you would hit enter to take you into editing mode. There's a little icon of a screwdriver in the upper right hand corner. It tells you you're in editing mode, and there's a box around the first parameter you can change. So by hitting the arrow key, you can scroll between different selections. To go to the next line, there's a next box, and you press the F2 key, moves down to the next line, and again you can scroll to make your selection. Once your selection, you have made your selections and you want to retain them, you have to hit enter to exit editing mode. That's the only way to save those measurements. Okay, so again, this document here will take you through each step, and as you step down through each parameter, you can refer back to this setting sheet and get the values you need to enter based on your system. So right here, the next screen, you see you set up the CT, and that's going to be the CT out on your switchgear that's monitoring the actual load you're trying to correct. So this needs to see all the current, all the load that you're trying to correct, including the capacitors. So placement of the CT is very important in order to get correct readings. So these are generally placed by contractors who are installing the switchgear or setting up the capacitor bank. And we need to know the value of that CT. It's usually on a one-line diagram, or the installer, if they're available, can tell you what value that CT is set for. And that value needs to go into here under CT. So if we want to make a change, again, you hit enter to go to editing mode, and you can scroll to different values. I'm going to change it to 2000. 2000 to 5, and that's the ratio that we're going to use. And the next line is a VT. That's going to be your voltage reference. So you hit F2 till the box highlights that value, and again you can scroll to different values. In this case I put in 120. I'm going to enter to save it, and then I move to the next parameter. Next parameter is looking for the secondary voltage from your reference VT, and that in turn determines the primary voltage on the VT. So if I change that value, it'll change the primary. As you can see. So it's important to get those right. They should match your drawings, match your design. Again, enter to save. We'll move to the next parameter. This is telling us how you're connected to the three-phase network. In this case, we're getting our voltage reference from line 1 and line 2, phase to phase. That would be phase A and phase B. The sensing CT is placed on C phase, L3, and we can select the polarity of the CT. And we can toggle between automatic, reverse polarity, or direct. And setting this up is important. It'll be a subject of a future video, but I'm just showing you the actual screen right now. Again, enter to save. Scroll down. We can select our target power factor. That's the desired power factor you want to achieve on your network, and that's changeable from lagging to leading, inductive to capacitive, and again, that's according to how you want your system to operate. Next screen is this is important. This is called response values, and this is determined by a calculation, which is, by the way, also on your setting sheet. And here's the formula right here. So we need to know the stage size of your first stage, your smallest stage, or your first stage, and we get that from the 3-line diagram, and that becomes the value in parentheses here, stage 1 kVAR. We also need the CT size, the CT primary current rating, and that would be what we entered earlier, in this case 2000. So we solve this equation with those values, and here's an example using a 2005. And that gives us this number here, this response value. And so once we've determined that value, we need to go into this panel, use the up and down arrow keys to enter that number. In this case, I'll put 0.2, and we do it for both inductive and capacitive. Make them the same, usually. Again, we hit enter to save and move to the next parameter. These next panels we don't use. They're used for low voltage systems, 480 volt, 600 volt systems, and it's a way for the meter to automatically go out and determine some of these other parameters we've already put in. So we're going to skip those. We won't use them. Reconnection delay, that tells us once a stage is open, how long will it wait to reclose the stage. In this case we use 5 minutes, 300 seconds, and that allows time for the capacitors to discharge before we close them back in. We want to make sure the capacitors are drained before we re-energize them. And this would apply to most voltages, say above 600 volts. We would use that value. Step program. This tells us how we want the controller to switch stages in. I won't go into the details of each program and how they work, but they can be, you can find that information in the Nokian capacitor operator's manual. And it determines, like I said, which stages will come on in which order, how quickly you get to your power factor, how evenly the switching is distributed between stages and so forth. This tells us how many steps we have. In this case, 1, 2, 3. We have 3 steps, and step sequence is telling us step 2 is twice the size of step 1. Step 3 is 3 times the size of step 1. And again, that's going to be on your 3-line diagram. Step 1 is 900 kVAR, step 2 is 1800 kVAR, step 3 2700 kVAR. So stage 2 is twice the size of stage 1, stage 3 3 times the size of stage 1, and hence the 1, 2, 3. This is just telling you which steps, which output relays on the meter you're using. We wouldn't change that normally, that's just for your information. And again, here's another automatic verification of C over K steps and wiring. We're going to skip that because we're on a medium voltage system, not a low voltage system. Manual connection of steps for testing. This you may end up using at some point. This is just a way of forcing the relay closed on this meter to bring a stage on or off. You can select the step. The plus key, you can energize a relay. With the minus button, you can de-energize a relay and in turn bring a stage on or off. It comes in handy sometimes, and it's good for testing all your wiring and the function of this meter. And the last panel is a Modbus information. If you're using Modbus, you can select the mode. Using the up and down arrow keys. Read, reset, read, write, and so forth. And you can also enter an address. Again, further information about this panel, it could be found in the NC12 user's manual. Okay, so that's about it for the setup. We can just keep hitting escape to bring us back out to the main menu, and you can see parameters is still selected. There's another menu option we might want to look at, and if we scroll down you'll come to another page, and line item here, alarms. You want to look at that because we need to set the alarms up. That's also on this setup sheet. And actually, I have it right here. There are 12 possible alarms, and your sheet should tell you where they need to be in terms of enabled or disabled. And there's a brief description of what the alarm is and also how it behaves. In order to get into the alarms menu, you hit enter. Again, it's asking for a code, and that's the minus and plus held together. And this is alarm number 1 out of 12. If you need to edit it, you hit enter. Again, bring it into editing mode. And you can toggle between enabled or disabled. Once you made your selection, hit enter to lock it in. And you can move on to the next. Alarm 2, 3, and you can scroll through the alarms, make the necessary corrections if required. And there's number 12, that's the last one, no more after that. Once you're done, you hit escape, brings you back to the main menu. And in this case, where everything is set up, we're going to scroll up to the measurements menu, hit enter, and that takes us back to your measurements. And that's it. Thank you.